people are waiting for me in Nearpod, so let's begin. First, our promise. Y'all know this? Participate, respect, be on time, stay muted, include your full name, stay in your seat, and eyes on me on the computer. What are we going to do today, Ms. Cruz? Today, I will identify forces. Forces, so I can explain and demonstrate how force can make an object move. You've been doing this for a while, so you should know. I know I have it when I can explain how force can change the motion of an object. All right, so we have our very first assignment here. Okay, you're gonna like this. We can organize objects based on the types of motion they have. Remember this? You can pull the picture into our Venn diagram. That's right, it's called a Venn diagram, where we can compare objects that push, pull, or both. Where does the both go again? Who remembers? Oh, Larissa, boy, you got a fast hand. Where should we put the both? Where should we put the both?
The both goes in the middle.
You are absolutely right. Is she right, guys? I think so too.
And I already got mine done.
Awesome. I'm going to peek in just a moment. I want to give everybody a chance. So thank you, love. All right, we've done this, and you guys should be experts at determining whether the objects can be pushed, pulled, whether the force is a push or a pull, or both. All right, let's peek. Look at Jaden's. Oh, yes, I see it. I agree. Pushing the, oh, yeah, that's great. The yo-yo. We talked about that the other day. That's fabulous. Oh, look at Capricia's. I agree. Oh, very nice. We can look at all of them, I think. Here's Arush. Wonderful. Oh, I like that pull on flying the kite. Yep, totally. Let's look at Abdul's. Abdul, the yo-yo. Have you ever used a yo-yo? So you push it down and then you pull it back up. I think I would switch something around. You'll go ahead and do that if you want. And let's look at Benito's. Oh, so when, you might want to think about it this way. What is the girl doing on the kite? So is she pushing it into the air, or is she pulling? Ah, yeah, I see. You can switch those around, totally fine. Let's look. Oh yeah, Francis, I see it. Pushing the ball, pulling the kite, and the yo-yo does both. And we saw Jaden's. Yes, very awesome. Larissa, wonderful. Let's look at Almost. Yep, I agree. And see Darth. Yep, absolutely. Walter, fabulous. And let me see, a couple people are still working on it, but that's true. Some of the times, it's not just what the object can do, it's the force you place on the object. That's what we really want to know. So what force is actually occurring? Yeah. And so when you're flying a kite, you're actually pulling the kite string to get it to go up in the air. All right, my loves. Beautiful. Let's move on. If you're not finished, don't worry about it. You can do it later. Okay. Here comes the next one. I love this one. We can make predictions to determine how an object's motion will change. Try some below. Prediction is your best guess. It's a scientific guess. So the first little boy says, I see that the ball is moving toward the ground. So what's going to happen is somebody's coming in, is what your prediction is. The next little picture says, I see that the ball is in his hands. What's he going to do? Is he going to push it away? So you're wondering what's going to happen next. What is the next force? And the boy in the wheelchair, what is he getting ready to do? And the girl, oh, look at the girl.
Teacher, hi teacher.
Good morning.
Oh,
Everything
now
okay?
you can see me.
I can see you.
My name is still my mom's name. They
Okay. It's
can.
okay. It's okay. Can you mute? Because I'm right in the middle of a lesson. I
I'm
love you though. Thank you for
doing.
staying.
Yeah.
Thank you for staying muted. All right. I like your background though. Hey, check out the girl on the end. She is about to do something with that ball. It is coming toward her. She looks like she's about to catch it. And what force do you think a catch is? Oh, that one's special, isn't it? All right, let's see how we did. Dun, 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 dun. Okay, so this girl, and if you want to act it out, you can. So imagine a ball is coming at you. You're going to grab it and pull it toward you. So the girl is actually pulling, and all the others are pushing them away. So every other one, you'll see that the the boy or the kid is pushing the ball. He's pushing it toward the ground. He's pushing it into the basket. He's pushing it toward his friend. And the only one that the girl is doing, and is very different, isn't it? There it is. I see it. Who's this? Francis. Yes. The little girl is going to pull it toward her. All right. So we have our answers. You guys are yeah, it's fine. You can match them up. Absolutely. Let's look at Brooklyn's. Very nice, Brooklyn. I love it. Yelini, you can change your answer. Try acting it out though. When a ball comes at you, pull it toward you to catch it. So the little girl, yeah, that was like magic right before my eyes. Fabulous. Thank you for redoing that. All right, let's look at Siddharth. Beautiful. And one more. Look at Aditya's. Yep. Oh, wow. Nice and red. Very nice. Okay. We are going to move on. So remember the little girl, you can redo this, but the little girl is the one who is pulling. So the last one in the light blue shirt, she should have her line go to the pull.
Did I did everything right, but except the girl?
It's okay. You can always fix it later. We're going to move on.
Okay.
You guys ready? Ready, ready, ready? Ready, Freddie. Okay, this is called a collaboration board. And let me see. You are going to write or draw to give an example of an object that can move round and round. You know what the one I think of? Huh. It comes from the sky. It turns round and round in a storm. And sometimes it can it can be really bad. It can be like knock over trees and houses. You guys know what I'm talking about? Oh, I have another one. What else goes round and round? Oh, I've got a good one. It's really, really big. It has land and water on it. It's in space and we live on it. Does that go round and round? Yeah. Awesome. Okay, go ahead and write or draw. And then what you do is you submit it or post it, like the word post. So I can do this. Oops, I can try to do tornado. And I can click post, and there's me. Blake, do you like tornadoes? I run away from tornadoes. What other things can we think of that go round and round?
Yep, definitely not.
Yeah, me either. I will run and hide if I see a tornado. How you guys doing with your collaboration board? Christopher, you okay?
Sure. Teacher. Teacher, you can hear me?
Are you posting on your collaboration board? Are you able to do this?
No, because I just put like a photo of planets already.
Okay, so can you tell me, is that something that goes round and round?
Well, yes.
Okay, very nice. A planet does go round and round, especially if it's rotating or revolving.
Only when the giant Earth goes like around and around with the giant thing around it.
Saturn?
Yeah, Saturn.
Oh, yeah, it's got the rings around it. That's true too.
Yeah,
All right,
yeah.
Larissa. Thank you, Christopher.
How do you like post it?
There should be a post at the bottom. Are you guys having trouble with it?
Yeah.
So I don't know if you can see my screen, but at the very bottom, it says the word post.
Yeah.
Let's see if I
Yeah.
can figure it out. No. No, it's showing here. Somebody needs to mute because I can hear their mom's phone conversation. We don't want that to happen. All right, thank you. Oh, yeah, okay. So let's move on. But there might be another collaboration board. Let's try this one. See if it works, and if not, let's just shout out answers, okay? What is an example of an object that moves back and forth? Back and forth. Back and forth. See if you can post on this one, and if not, go ahead and unmute and yell out what you think can go back and forth. Ooh, we have answers. They're coming. A swing. Here comes Abdul's. Who else? Aditya, a swing. I agree. I like your picture, Abdul. Ooh, who else is coming? Let's see. A rocking horse. Yeleni, nice job. Yeah, I agree.
Seesaw.
Yeah,
Actually, not a seesaw.
a seesaw. Oh, what
No.
does that do? That does something else, doesn't it?
Oh, I would rather choose a swing like Abdul.
Okay. I think a lot of people are thinking the same thing as you guys. You must collectively be reading each other's minds. Swing and rocking chair. Ooh, look at this one. Francis has a different one. You ever sit in a car in the rain and mom or dad puts the windshield wipers on? Those wipers on the front windshield and they go back and forth. That's a good answer. I like that answer. It's very creative. Mm-hmm. Anybody else? Let's do another 10 seconds. We have swings, rocking horses, and the wipers. Oh, somebody else is coming in. Let's see. A yo-yo? Okay, think about the yo-yo for a moment. Does that go back and forth? It could. Oh my goodness. I think I'm thinking the way you're thinking. It can do several different motions, can't it? And I saw a trick many years ago where this yo-yo master, he made the yo-yo in a triangle and then he would swing it back and forth. It was really cool. That's an interesting answer. Okay, here comes more. A pendulum, Siddharth. That's a really interesting answer. A lot of people don't know what a pendulum is. Do you want to unmute and tell them?
It's like a toy ticker. It goes back and forth.
Yes, I've seen them in clocks, and they have that little pendulum, the swinging thing that goes back and forth at the bottom of the clock. Wonderful. All right, guys, let's move on. Look at that rocking chair picture. That's too cool. All right, guys. And here comes the fastest thing on the planet. Draw an example of a push on one side and a pull on the other. Now I get to see your artwork. If you can't do this in Nearpod, you can show me a picture, hold it up, draw me something that can push, a force that is pushing, draw me something that is pulling. Oh, that's cool. Yes, you could pull the flower. That's wonderful. Oh, Jaden, what an artist. Siddharth, I see it. That looks great. Now, I'm going to tell you something right now that you need to know that's extremely important. Okay. So, in math and science, you're going to hear me say a lot. Label your pictures, label your diagrams. Label means to put a word next to it or several words so that when another person looks at your picture, they know exactly what they see. In Nearpod, it's difficult to write words on there. It is, I get it. But when you're submitting your diagrams and pictures to me, we are definitely going to start asking you to start labeling them. So, and then I'll be asking you to resubmit with labels. So I need to be able to look at your pictures and diagrams, and I need to know exactly what I'm looking at. So we use little words and arrows to point at what you have drawn. So if I have a picture of a tree, I might draw a little word next to the leaf and say that's a leaf. And I might draw a picture next to the trunk and say that's a trunk. So it's labeled, okay? So if your family is nearby, just understand that good scientists, good mathematicians, we always label pretty much all our pictures and diagrams. Beautiful. Look at you guys. I can see it. You guys can see everybody's work on here. Oh, it's so good. Look at Arush. That's great. Throwing the ball and pulling a kite. Oh, look, Larissa's throwing the ball. That's pushing it away from you. I like that. There's Jaden pushing the ball and pulling a door, it looks like. Wow. Oh my goodness, you guys are real artists. This one. Wow. Who's that? Aditya. Very nice. Look at, oh, you're pulling. Is that like a wagon? That's too cool. Yes. Oh, look at this. Abdul. Oh, I see it. You're catching the ball. That's pulling. You're right.
You can show mine.
I'm working on it. Don't unmute. Okay, let's see. Almo, very nice. Oh, look at the kite. And he labeled it. Oh, Almo, you are totally right there with me. Excellent. Okay, let's look at Yelini's. Yeah, I see it. Kicking the ball and then catching it. Wonderful. Let's
What
look at
about
Blake.
mine?
Oh, Blake, that looks great. I see it. What are you pushing? What's that you're pushing?
It's a box.
Wonderful. I had to push a big box the other day. That's so right. So in the future, you would write the word box on it so I would know what it was, wouldn't you?
What I'm pulling is a
What were you
rope.
pulling?
A rope.
Oh, cool. All right. Let's look at Brooklyn's. Oh, look at her. She's labeling. And that's a great example of labeling. Okay. So just write down what it is you're drawing. Just kind of write right over it. Okay, there's Siddharth. There's that. Is that the yo-yo?
The pendulum.
It's the pendulum. Very nice. Okay, and then, oh, there goes my dog. Hold on. Let's go to the next one. Wonderful. While my dog barks his head off. I want you guys to, and you can do this all together. Can you think of anything else that might have a force? Think about that for a moment. We have, it's not just people. It's not just people, right? It's not just objects that you have around the house that you can force around, right? So there's other things in the world, in the universe, that has a force. Can you think of what it could be? No, you have to push that. This has a force all by itself. You don't have to use any kind of pushes or pulls on it. All right. Oh, Siddharth, what do you think it is?
Gravity.
Oh, you know it. Well, what has gravity, Siddharth?
One.
What, say it one more time.
One.
What has gravity?
No, what did you say?
What has gravity? What is it that, what big object has gravity?
Earth.
Yeah. And that's a picture of Earth too. So did you know that part of our lesson, I kind of told you that um I think a couple about like a week ago, I told you that you are going to need to know about force because there's something really big that we have to understand. Its force. It also has a pulling force. So let's move on, and you're going to watch a cute little video, and then we're going to talk about that. It's very quick, okay? But I do need to share my sound with you. I'm trying. I am. There it is. Found it. Okay. While you're watching the video, I will check the chat and make sure I didn't miss anything, okay? So again, there is something else that has a secret invisible force that pulls. Save your talk about Beyblades till tomorrow. Please don't write in the chat about that.
Hi! Today we are going to do some experiment and gravity. Let's start it, guys.
Okay, can you guess which one will fall down first?
Bye.
Shall we see? Okay, drop both objects at a time. Now can we see which one will drop down first? Okay, at a time, come forward. Okay, drop down. Very good.
This is the ring me.
Drop it. Now can you guess which one will fall down first? Okay. Come forward. Drop it. At a time. Very good.
Right? Yeah.
Okay, try it. That is a paper ball and you are holding the sweet lime. Which one will fall first? You are taking both hands. Which one? Okay, let's see.
Are my friends? Good.
Almost done.
Very good. The car. 1, 2, 3, go. The car is fun. Thank you very much.
All right. What in the world did we just watch? Well, let me tell you something. You think you need to know this. Did you know that something is pulling those objects down to the ground? And I'm pretty sure Siddharth knows the answer to this one. So there is this invisible force that we're going to learn a lot more about later in the year. But I wanted to extend the thought about pushing and pulling forces to something bigger and greater than just what people can do. So you have to stop and think about the fact that you're walking around on the ground right now. You're sitting down on the ground. And if we didn't have something pulling us down, you would float away. That's right. I would see Brooklyn float off into outer space. No, Brooklyn, come back. What if Jaden started floating away? Oh my goodness, what if Francis started floating up to the ceiling? So something is pulling you back down to the earth, and that is an invisible force. Force, yes, called gravity. So points to Siddharth. Nice job, you knew it. So you guys can test out the same type of experiment that our friend did in the video and test out with unbreakable objects. Make sure you get permission from your family. What can I drop? What can I not drop? And watch. Don't throw it at the ground. Drop it. Just release your hands and watch it be pulled down to earth. Just like you're being pulled down right. Oh, oh, I'm almost done. Just like you're being pulled down right now. Just like your family's being pulled down to the ground right now. Okay. We're going to have a lot more lessons about gravity coming up in the future, but I wanted to tell you about the fact that there is something else that's got gravity. Now, very quickly. Oh, do we have a question before I go on? Question about gravity? No? Okay. So I'm going to move on. What does a scientist do? This is so fast. A scientist asks questions. Yeah, they always have questions. They always want to know things. That's what a good scientist does. They wonder, I wonder why. I wonder how. You're going to do that in a moment. Get ready. We hypothesize. That's where we believe something will happen. And we think about what it's going to do. We observe with all of our senses, not just our eyes. Okay, you observe with all of your senses. You can infer, I think, and then research. Yeah, go back and see what other people have done. You analyze. That means you go back and sort of look at what happened, right? And then you sort and classify. A good scientist always sorts and classifies, kind of like your family does with your socks. They sort them and they classify them. Let's put all these dress socks over here. Let's put all these socks over here. That they do that in science all the time. We measure. Oh, it's kind of like with math. Yeah. We do experiments just like our friend did in the video. And we predict. You know that word now. A prediction is your scientific guess of what you think will happen, and record our data. We always write down everything that happens. So I wanted to talk about that with you because a lot of kids don't know what scientists do, and we do a lot, and we're very careful about the things we do. So this is our final, we're at the end of our lesson, and we wanted to talk a little bit about what you wonder about. Okay, so it's another one of those collaboration boards. We're going to try to get this one to work. And I want you to stop and think about something that you wonder how it happens. How does a rainbow happen? Or why doesn't the rain fall up? Or why are the trees green mostly? Why do trees lose their leaves? Okay, so I want you to stop and think about something you wonder about, right? Why do dogs walk on 4 legs? These are all scientific questions. So think about something that you wonder about. Either type it in and then click post, or you can draw a picture. Oh, here comes one. Good scientists always wonder. Walter, you want to try again? And that's what I would write. I'm going to actually write mine right there. Why do dogs and cats walk on 4 legs? There you go. There's mine. Why can't we see air? Let me think. How about why can't we float?
That was a good question.
Yeah, right? Very scientific. Thank you. Let's see. Ooh, how was the dictionary made? Very nice. Okay, I like that. These are wonderful thoughts. All scientists and inventors always stop and think, well, why can't we do this better? And how can I make this easier? Oh, here comes another 2. Oh, we got 2 more. Can't wait to see them. Francis, what causes earthquakes? Oh, Abdul, how do we sleep and wake up? Wow, what a scientific question. These are things you can research. Jaden says, how is the rainbow colorful? Oh, what a great question. Almo says, why do the tree leaves, why are they green? Wow, there's so many good reasons for all of these. Yalini just says, why? Why? I don't know why. Oh, here comes another one. Oh, how come we can't see air? Exactly. Arusha's the dog. That made me laugh. I love it. Look at the dog. And why do they have 4 legs? Oh, you guys crack me up. Here comes another one. Why did the dogs put their tongues out? Ooh, that's a good question. Do some research. Find out. Yeah, get your parents' permission to maybe do a quick Google search, and you'll find out why these things happen. And you'll be able to answer questions. And in those cases that you can't answer them, you might have to think about doing an experiment to find out why things happen the way they do. All right, my loves. A good scientist always wonders. Let me see. I wonder how dinosaurs can't come to life. Well, I'm kind of grateful for that, but okay. And then I can't read Prisha's. So maybe what you want to unmute and tell me what yours says? You there, Prisha? Are you redoing it?
I
Yeah.
made a mistake and it's not redoing.
Oh, okay. Tell me what it says.
It says, why do? That's all it says.
Okay, what did you want to tell me?
Why do we walk on 2 legs?
Do we walk on 2 legs? That's from Prisha. Are you looking for your keys, huh? They're by the TV. Okay. Oh, and we had, why are dogs and cats angry? Angry. Oh my goodness. Yeah, I don't know. Our neighbor cat likes to be angry at my dog sometimes. Okay. These are fabulous questions. We're going to get going because you guys have been on a long time. How comfortable do you feel about explaining and demonstrating force and motion? I've got this. No problem at all. I know about pushing and pulling. I noted how to demonstrate it. I know.
Are we almost finished?
Yes, yes, yes. This is it. B, I got this. No, but I need a little practice. Okay. And then C, I need a lot of help. I can't remember which is pushing and pulling. I can't remember the forces. I can't remember how to change direction so well. I can't give examples. So I see a lot of great answers, and we are done. Please remember that I am about to invite you all to a party tomorrow. So let me
A party?
I'll tell you again. Hold on. Let me stop sharing. Hi. Okay, so yes, let me explain it one more time real quick. Here comes Walter. We are going to have a party tomorrow at 2 p.m., 2 o'clock, 2 o'clock. I'm going to send the invitation in GroupMe. And Miss Wood might have already explained it in her email too, but look for the GroupMe text. 2 o'clock tomorrow, we'll have some parties, some games, and say hello and goodbye to each other for those kids that are leaving. And then for Miss Wood, we definitely want to say goodbye to her, okay?
Teacher.
Yes.
So tomorrow I can bring my phone.
Good neighbors,
Bye.
good kids, good schools.
And we're gonna play some games tomorrow, like online games, you know.
Bye.
Fun.
Help a
Bye.
granny. Help a
Love ya.
granny with a bat. Teacher, help a granny. That's a
I don't
game I
know.
downloaded. I downloaded gradually and
We're not gonna play online games. We're gonna play games together, okay?
Okay. And I'll
All
find
right.
some on my phone. Bye.
Okay. Bye,
Yeah,
Mommy.
granny
Have a
there,
good
so-
day. Mwah.
Bye.
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 Bye.